Hello and welcome to the GCSE Science Tutor. Today we're looking at Lesson 5, Electronic Structure. Before we look at electronic structure, let's recap atomic structure from the last lesson. Have a go at answering the following 4 questions, pause the video and I'll go through the answers in a few moments. Question 1. What is the definition of atomic number? Well, in fact, we can get the answer of this from our periodic table. If you look at the key, you will find the word atomic number with the word proton in brackets. That is actually telling us that the atomic number means the number of protons. And this is a definition you need to learn. Question 2. What are the charges of a proton, neutron, and electron? This is something we can work out by simply looking at the words. The word proton begins with the letter P, and it is in fact positively charged. A neutron sounds like the word neutral, and in fact has no charge. An electron, however, does not sound like the word negative, but through the process of elimination, we know that negative is the only charge left. So it is -1. Question 3. How many electrons, protons and neutrons are there in an atom of potassium? Looking at the symbol up here on the right, we know that the top number is our mass number. Again, we can get that from the key of the periodic table. The bottom number is our atomic, or in bracket, proton number, again, found on the periodic table. Using these numbers, we can work out the protons, electrons, and neutrons. The number of protons, we simply look at the bottom number, and it tells us we have 19 protons. Protons are positively charged, and there must be the same number of positives as there are negatives. So we also have 19 negative electrons. To work out the number of neutrons, we simply take the bottom number away from the top number. 39 take away 19 leaves us with 20 neutral neutrons. And finally, question 4, why is potassium atom described as a neutral atom? Well, again, if we look at the previous question, we can see that we have the same number of positive protons as negative electrons. Electronic configuration. As the name suggests, this tells you how the electrons are arranged around the nucleus and shells. So first of all, we need to remind ourselves that this has 19 electrons in an atom of potassium. So let's just jot that down. When we are drawing the electronic configuration, write the symbol of the element in the middle to represent the nucleus. We can draw a shell by simply drawing a ring. The electrons are represented by crosses, which I'm going to do here in a different colour. The first shell can hold a maximum of 2 electrons, and I will place them in like that. I am now going to draw a second ring to represent the second shell, which can hold a maximum of 8 electrons. It is a good idea to draw your 8 electrons going round in a circle like this, as it will be useful for when we do bonding in the next topic. I now have 10 electrons in total and 9 left, so I need to draw another shell. And I'm going to place the next 8 electrons in this shell too. Again, going round in circles and keeping the electrons in pairs. I now have a total of 18 electrons, so this means that I have to move on to the next shell because my third shell can again only hold a maximum of 8. And I'm going to put my final electron in this shell here. We can also write the electronic configuration as this: 2.8.8.1 to show that there was 2 electrons in the first shell, 8 in the second, 8 in the third, and 1 in the fourth shell. Pause the video now and have a go at beryllium and sodium. I will then go through the answers in a few moments. If we take beryllium, we can see that the atomic number is 4, which means 4 protons. That must also mean it has 4 negative electrons. So let's take a note of that. We're going to write the symbol in the center, followed by the first shell, which can hold a maximum of 2 electrons. 1, 2. Now we have 4 electrons to draw, so we need to draw another shell. And I'm going to place the next 2 electrons in this shell. And that gives us an electronic configuration of 2.2. Now let's look at sodium. Sodium has an atomic or proton number of 11, which also means that it has 11 negative electrons. We're going to draw the symbol in the center, in the middle, to represent the nucleus and the first shell. The first 2 electrons are on the first shell. We're going to draw the second shell, which can hold a maximum of 8. 1, 2, 3, 4, 5, 6, 7, 8. We have 10 in total, so we need to put the final 11th electron in the third shell. We can now draw our electronic configuration as 2.8.1. The periodic table is made up of columns and rows. However, in chemistry, we don't call them columns and rows, we call them groups and periods. Groups are the columns which go down the periodic table. So take your periodic table and label groups along the top. There are in fact 8 groups, group 1, 2, all the way to group 0. We call the middle block the transition metals. They don't have a group number as such. The rows of the periodic table are called periods. So again, write the word periods on your periodic table. Now it's important to remember that hydrogen and helium both belong in period or row 1. Lithium and beryllium start row 2 and number it all the way down to francium, which forms period 7. Many students often assume lithium is the start of period 1, but that is in fact incorrect. It is hydrogen and helium. Here is your next task. Copy the table below and fill out for each element the number of electrons, the electronic configuration using the number of electrons, the group and the period from the periodic table. I will do the first one with you. So we looked at beryllium before. Beryllium has an atomic number of 4, which means it has 4 electrons. 2 of those electrons will go in the first shell, followed by 2 in the second shell. So that's its electronic configuration, 2.2. If I then look on the periodic table, I will see that it is in column 2, or group 2, so I'm going to fill that in here. It is also found in row 2, or period 2, which I'm also going to write here. Now you do the rest, and I will go through the answers on the next slide in a few moments. So hopefully your answers look like this. Now let's see if you can relate the electronic configuration to the group number. You may notice a pattern. Pause the video now and see if you can work it out. Well, if you take each of the final numbers of the electronic configuration, you will notice that they are in fact the same as the group number. For example, 2 and 2, 1 and 1, 2, 2, 6, 6, 7 and 7. So in fact, the number of electrons in the outer shell of an atom is equal to the group number. What about the period number? Can you see how the electronic configuration relates to the period number? Pause the video again and see if you can spot the pattern. Well, this time, if you take the period number 2, you will see that there is in fact two numbers, 1, 2. A period number of 3, there is 3 numbers here, 4, 4 numbers, and the same with oxygen and chlorine. So in fact, the period number tells us the number of shells in the atom. And these are two very important links. So I would suggest that you write both of these down, that the group number is the same as the number of electrons in the outer shell, and the period number is the same as the number of shells. A really common question in exams. And finally, let's check your learning from the lesson. Without using your periodic table, answer the questions below. An atom has the following electronic configuration: 2.8.5. Pause the video now and I'll go through the answers to the following questions in a few moments. Question 1. What group will this atom be found in? Explain your answer. Well, we can see that we have 5 electrons in the outer shell, so therefore it will be found in group 5. So we would write our answer something like this: group 5 because there are 5 electrons in outer shell. Question 2. What period will this atom be found in? Again, explain your answer, which means give reasons for. Well, we have 1, 2, 3 numbers here, which suggests it has 3 shells. So therefore, it will be found in period 3. So again, we can write our answer something like this: period 3 because there are 3 shells. It is important when you're asked to explain something to give a reason for something, and often the use of the word because is a really good way to do that. Question 3. How many protons will this atom have in a neutral atom and why? Okay, well, we know that there is a total of 15 electrons because 2 plus 8 plus 5 gives us 15. Now we know that electrons are negatively charged, so therefore, in a neutral atom, there must be the same number of positive protons, which must also be 15. And finally, if the mass number is 31, how many neutrons does this atom have? Well, if we were to take the symbol of this atom and call it element X, we know that the mass number, the top number, is 31. We also know the proton number, or the atomic number, is 15. So to work out the number of neutrons, we need to do the top number minus the bottom number to give us an answer of 16 neutrons. The next lesson in this unit, we're looking at Lesson 6, History of the Atom. Thank you for listening to the GCSE Science Tutor. Remember to like and subscribe to get further updates on lessons and tutorials.